In today's video, we will look at different types of number sequences and the different patterns. So we have 4 examples. Let's start with the sequence UN. Its first term is 4, its second term is 7, its third term is 10. So we can notice that to get from one term to the following one, we add 3 each time. So we have a common difference, positive 3. For the sequence AN, to get from 22 to 18, we subtract 4. To get from 18 to 14, we subtract 4 again, etc. Subtracting a number is the same as adding its opposite, so we still have a common difference, which is -4. Sequences like these two, where we add the same amount each time, are called arithmetic sequences. It's a very common pattern. We find it very often. In finding a regular pattern, we can determine what the nth term of such sequence is. Let's have a look together. So, a sequence starts with U1. Okay. To get from U1 to U2, we add the common difference, D. So U2 is equal to U1 plus 1D. To get from U2 to U3, we add D again. So U3 is equal to U1 plus 2 times D. And so on. So UN is equal to U1 plus n minus 1 times D. So we have a formula for the general term of such sequence, which is very useful. Why? Because thanks to this formula, we can determine any term of this sequence. For example, if I want to determine what U21 is, I can do it now. And for that, I will substitute 21 for n. So I will get U21 equal to 4 plus 21 minus 1 times 3, which is equal to 64. However, all the sequences are not arithmetic. Let's have a look at this sequence Vn. To get from 3 to 6, we add 3. To get from 6 to 12, we add 6. Therefore, this sequence is not arithmetic. But to get from 3 to 6, we multiply by 2. To get from 6 to 12, we multiply by 2 again, etc. Each time we multiply by the same number. So we have a common ratio, 2. And finally, our last example, the sequence Bn. To get from 27 to 9, we divide by 3. Same to get from 9 to 3, etc., which is the same as multiplying by 1/3. So here again, we have a common ratio, which is 1/3. Sequences like these two, where we multiply by the same amount each time, are called geometric sequences. Let's have a look at what the general term of such sequence could look like. So it starts with V1. To get V2, we multiply V1 by the common ratio R. So V2 is equal to V1 times R. To get the following term, V3, we multiply by R again, so we have V1 times R power 2, and so on till Vn. So Vn is equal to V1 times R power n minus 1. Once again, now we have the general term of such sequence. We can easily calculate any term of this sequence. For example, if we want to determine the 10th term of the sequence Vn, we can substitute 10 for n and the common ratio 2 for r, and so we can easily calculate V10